Dear all, today we are going to discuss about fundamentals of computing. So, we'll start with what is meant by counting, then followed by what are the different rules for counting, and we are going to solve some of the problems on counting. If you look at the word count, it is nothing but counting the total number, how many numbers are there in the list. So that is what the general meaning of count is. So it is also called as an act of counting. Okay. So these particular techniques for counting are very much essential in case of mathematics as well as discrete mathematics and also in computer science and engineering field. So this fundamental counting principle is a particular rule which is used to count the total number of possible outcomes in a particular situation. So we are going to discuss some of the counting principles in case of discrete mathematics. So basically there are two different ways in order to count any numbers. So quite generally which are used are sum rule and another one is product rule. Okay, coming to the first one, which is called as sum rule. As the name itself indicates, we are going to find out some sum in case of counting. Now assume that there are two different events, A1 and A2 be two different events. Okay, so where in which event A1 can happen in ways, m ways, and event A2 can happen in m2 ways. So there are two different events A1 and A2 and they are going to happen in m1 and m2 ways. Another important thing is these events A1 and A2 cannot happen at the same time. So that is what parallelly these two cannot happen at the same time. So then this either of two events A1 or A2, these two can happen in M1 plus M2 ways. So without happening at the same time, either of these two events A1 or A2 can happen in M1 and M2 ways. So this is what the sum rule is. So if I talk in general, let us assume that there are n different events, that is A1, A2, A3 up to AN, which are going to happen in m different ways, that is M1, M2, M3, M4 up to M1 ways. Okay, such that no two events can happen simultaneously. So that is the one thing which is the condition. So in such case, the number of ways of happening of one of the events can happen of events of A1, A2, A3 up to AN is M1 plus M2 plus M3 up to AN. So this is what the general rule of the counting. So right, with this we are going to solve some of illustrative examples in the initial stages. Suppose there are 6 pens and 4 different pencils for writing. Very simple problem. Okay. So these selected either uh, pens or these pencils can be selected in these many number of ways. So 6 is for pens and the 4 is pencils. So this is what the total number of possible outcomes or total number of possible ways for selecting either pens or pencils. So that is 10. Okay. There is another second simple example. In an circulating library, 5 each of Sudha. So these are all weekly magazines. 5 each of Sudha. Then Taranga weekly magazines. Okay, there are two different. One is Sudha and Taranga. Then there are four different magazines, each of Kasturi and Mayura, which are monthly magazines. So, in a particular library, a member of a library wish to choose the magazine for borrowing. So, how many number of possible counting? So, there are five. Okay, this is five for Sudha, five for Taranga, four for Kasturi, and four for another one is Mayura. So, the total number of ways the member can choose a particular magazine for borrowing. Borrowing is 5 plus 5 plus 4 plus 4, which is equal to 18. In 18 possible number of ways a person can borrow. Okay, there is another interesting example which is uh, given below. So let us consider a rolling out two different dice. Okay, a dice which is having six faces. We shall determine the number of ways of happening of either of the following events. So there are two different events which I have mentioned here. So what would be the total number of possible? Okay, the first one is getting the even number on both the sides, and second one is event 2, the sum of total numbers on the two dice is odd. So event is rolling out two different dices. So now if you look at first one, so both of even number. So it is 2, 2, 2, 4, 2, 6. It may be 4, 2, 4, 4 and 4, 6. And even 6, 2, 6, 4, 6, 6. So these are all the possible phases will be of even type. If you count, the total number will be 9. So here the total number of outcomes for event 1 will be this 9. Now similarly, when you look at sum of two numbers on the dice is always odd. 1 2 1 4 1 6, 2 1 2 3 2 5. You add these all these numbers, it will be of 7. So now here 2 3 is 5, 3 4 is 7, so it is 9. So 4 1 4 3 4 5 5 2 okay 5 1 okay 5 2 5 4 6 1 6 2 6 6 3 6 5. So if you look at 3 6 9 12 15 18, so you will have 18 numbers which is of this. So this is 5 6, you can take it as 5 6, so it will be 11. So now if you look at this total values will be 18. So now the total number of events that can happen here is this plus this. So that is what here I have mentioned here, 9 plus 18, which is equal to 27. So for this particular problem, the total number of ways happening of event 1 or 2 will be 27. So next is product rule. Let A1 and A2 be two different events which will happen one after other. So where event A1 can happen in M1 ways and event 2 will happen in M2 ways. So then both the events can happen in M1 dot M2 ways. So this is what my product rule is. In general, if A1, A2, A3 up to AN are the different events such that A1 can happen in M1 ways. Similarly, A2 can happen in M2 ways, and in general, AN can happen in Mn ways. Then A1 is followed by A2, followed by A3, up to followed by AN in a sequential order. So in this case, the total number of possible ways will be M1 dot M2 dot M3 up to M1 ways. So we'll see some of the illustrative examples on product rule. A TV channel has three gents and two ladies as a newsreaders to telecast a news bulletin with a combination of both. Okay. In such case, what are the different possible ways? If you look at the possible combinations, if I write, okay, so G1, G2, G3 is uh, girl number of gents. L1 and L2 will be number of ladies. So which is this, I will call it as M1, and this I will call it as M2. Then according to this product rule, the possible number of combinations as derived will be 6. Okay, so that is M1 into M2. If you perform with this, 3 into 2 is which is equal to 6. Now to cross verify, if you look at G1 and L1, G1 and L2 is one combination. G2 L1, G2 L2, G3 L1, G3 L2. So these are all 6 different combinations where the different events can happen. So this is also 6, and here also you are going to get it as say 6. So this is about problem number 2. Now other one, which is a customer wants to change ATM pin which has 4 digits. So that is, your ATM should have 4 different digits. The numbers of ways it can happen with repetition is this many, because you have 0 to 9 numbers. So totally then in that case there will be 10 numbers. So your first number, so say first number can be anything between 0 to 9. Then another one, second number also can have any numbers between 0 to 9. Third number also between 0 to 9, that is also 10. And the last number also you can have any number between 0 to 9 since it is with repetition. So your password 4 digit contains will be 10 into 10 into 10 into 10, which is 10,000. Now at the same time, the number of ways without repetition, when I say without repetition, this number you have options of 10 numbers. So 10 numbers. So in that case, you have taken one number already. So number of remaining digits will be 9. So I have taken here 9. So now what happened? Two numbers you have selected. Those two numbers should not be repeated here. So number of digits left here is 8. So I have taken it as 8. And the last number, yeah, already three numbers are there. These three numbers, leaving these three numbers, one more number is say 7. So 10 into 9 into 8 into 7, which is 5040, is without repetition. Okay. In the similar fashion, we are going to solve another problem where The internet banking customer wants to set a password comprising of 6 English by alphabets by 2 digit number and followed by 2 digits number. Okay, so the possible number of ways. So if you look at 6 places, so first number you have say 26. Second number also you have 26. Third number also you have 26 options. It is digits. Fourth number, fifth number, and sixth number. All these are all repeated. So hence, I will take it as mm, numbers as digits. Sorry, password as a digits. Now they followed by two letters. So one is X, another one is X. This is so this number will be 0 to 9. So that is why it is called as 10. Second number is also called also is 10. So that is why it is 10. So with repetition, your different number of ways that can happen is 26 to the power of 6 into 10 to the power of square, and that is 2. Now, if you look at with repetition, this is without repetition. Okay, so without repetition. So first number, as I told earlier, 26. This will be 26. One number is already taken. Left out is 25. So 25 digits. So this also now you have taken it as 25. Remaining digits are 24. Like this, you will complete till this part, which is 24 into 23 into 22 into 21. Now this digit 0 to 9, so I have taken it as 10, and this digit I have to take it as 9 because already one is taken here. So 10 into 9. So this number would be your with the number of possible ways where the password can set using 6 digits alphabets and 2 digits numbers, 6 English alphabet letters and 2 digit numbers out of 26 digits and 10 numbers. Okay, next is permutation and combinations. So permutation. So what is permutation means? Permutation means arrangement of things where the word arrangement is to be understood in perspective that order of the things is necessarily considered. Okay, this is what the important thing is, where order of the things is considered while making arrangements. So if you are there are n things, okay, permutation of n things which are taken or at a time is to be understood as arrangement of or things in all possible ways, in all possible ways. So always this r should be less than or equal to n. Okay, so this permutation will be represented by two different notations. One is npr, another one is p of nr. So both are same. So both are ways to represent this particular permutation. So other one is combination. The combination of or things taken at or at a time is to be understood as the selection of r things out of n things where r is less than or equal to n. Okay, so if you look at the notation for this is ncr or c of nr or in the bracket n and r. Okay, so now we will see the two different examples. how you are going to arrange based on the permutation and combinations. If you look at the permutation, there are two different things, A and B. So arrangement taking both at a time will be like AB or BA. So this is will be considered as one way, a BA is considered as another way. So this is two ways. Even if you find 2p2 now, uh, two elements and two r is n is equal to 2, r is equal to 2. So npr is equal to, now here it is 2. So now selection taking both A, B or BA, here is both are considered to be the same way. So that is why I have written it as 2C2 is equal to 1. You take another example, A comma B comma C. Arrangement will be like ABC or ACB or BCA or BAC or CAB or CBA. So which contains all these three elements. Okay. So now it is 6. So selection taking all three at a particular time is only one way in case of combinations. All it will be treated as only one way. Okay. So now this is what the definitions and illustration examples of permutation and combination. Now another one is the factorial of n and n being a natural number. Okay, the product of all first n natural numbers, that is from 1 to n, is called as n factorial, or it is also called as factorial n. It is denoted by these two, n factorial or factorial n. So that is, if you write n factorial is equal to 1 into 2 into 3 into 4 dot 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 up to n times, or n into bracket n minus 1, n minus 2, 3 to 1 in the reverse order. Even if you write like this, that is also called as n factorial. Okay, so now if you look at the 0 factorial is equal to 1, which is already known. So I can write it as another one, n factorial is equal to, even I can write it as n into n minus 1 factorial. Even if I extend n into bracket n minus 1, n minus 2 factorial, whatever the last number you are going to take, for that you have to take factorial, and the previous element numbers will be like 1 less. So this is what n factorial is equal to, n into n minus 1 factorial, and which is equal to n into bracket n minus 1 into n minus 2 factorial. Okay, now I'll represent this in terms of P of nr. So if you look at, uh, let us suppose that we have n different things, that is x1, x2, x3 up to xn. Okay, here the permutation being arrangement of things. So when you are arranging this, the first number can be filled in n ways. Okay, so next term will be like leaving one place, so you will have n minus 1 ways. Second place will can be filled by n of n minus 1 ways. Okay, then the number of things left after these two will be n minus 2 ways. So similarly, this next third place, first place is of n, second place is n minus 1, third place is n minus 2. Like this you can fill all these different places. So similarly, like this, you can have rth place, which is by n minus r minus 1. Okay. So now I will apply multiplication rule. The total number of ways filling up first, second, third up to rth place will be this one. So that is n into bracket n minus 1, n minus 2 up to n minus r minus 1. So I will call this as equation 1. Okay. So now the equation 1 or expression 1, now it will be like, since r is less than or equal to 1, I can write n minus r, n minus r minus 1, n minus r minus 2, 3, 2, 1. So I can write it at the equation 1 as like this. So p of nr minus 1 will be n into bracket n minus 1, n minus 2, n minus r minus 1. So what I will do is I will multiply and divide by this. So which is same thing. Okay. I'll multiply with this and divide it by this. So numerator, if you look at n minus 1, n minus 2, n minus r minus 1, if you look at this, it would be n factorial. So this I can write it as n minus r factorial, n minus r factorial. So p of nr, I can write it as n factorial divided by n minus r factorial without repetition. Without repetition. So with that particular problem uh, step, I can write p n of n, that is n factorial divided by n minus n factorial, which is equal to n factorial divided by 0 factorial. So 0 factorial is 1, so it will be n factorial. Okay, next is for C of nr. So every combination is comprised of r different things which can themselves arranged in r factorial different ways. So for a single combination of r different things, there are r factorial arrangements. Okay. Now if you look at this one, so C and R combination is, the number of arrangements is obviously C of nr into r factorial. So which is equal to the number of permutations what you are taking is r at a time, that is p of nr. So I can write it as C of nr into r factorial is equal to p of nr. So using this in the previous equation number 2, I can get it as ncr into r factorial, which is equal to n factorial divided by n minus r factorial. If I write only ncr, so n into bracket n factorial divided by n minus r factorial. This r factorial if I bring here, so n factorial divided by n minus r factorial into r factorial, which is my ncr. Okay, so if you look at npr as in equation 1, ncr is equal to, this is n minus n into bracket n minus 1, n minus 2, the same formula, divided by r factorial. So replacing r by n minus r in the previous equation number 4, you are going to get these two equations, that is n factorial divided by n minus r into bracket n minus r. So just you are replacing here, I will get it as n factorial divided by n minus r factorial into r factorial. So if I write like this, so even I can write it as ncr is equal to ncn minus r. So this is, I'll call it as equation number 6. So these are all the things you need to remember. Now we are going to solve some of the problems on npr and ncr. Find the values of n in following cases. np2 is equal to 132. Very simple. I know that np2 is npr is equal to n factorial divided by n minus r factorial. I'll apply here n factorial divided by n minus 2 factorial is equal to 132. So this I can write it as n into bracket n minus 1 into n minus 2 factorial divided by n minus 2 factorial. So this and this will get cancelled. I have left out with n into bracket n minus 1 is equal to 32. So n into bracket n minus 1 is 132. If I find n square minus n is equal to 132, which is in turn n square minus n minus 132 is equal to 0. So if you factorize this, I am going to get these two values, n minus 12 into other bracket n plus say 11. So which is equal to n minus 12 is equal to 0, okay, which will give you n is equal to 12, and n plus 11 is equal to 0, which will give you n is equal to minus 11. So but only these positive values will be accepted because n cannot be in terms of negative. So n is equal to 12 for this particular problem. So another problem which is np3 is equal to 3 into bracket np2. Okay, so I know with this I can write n factorial divided by n minus 3 factorial, and here 3 as it is I have kept. Then np2 is n factorial divided by n minus 2 factorial. So this n factorial divided by n minus 3 factorial, I can write it as n into n minus 1, n minus 2, n minus 3 factorial divided by n minus 3 factorial. So this will get cancelled. So I left out with n into bracket n minus 1, n minus 2. So here 3 into, if you find this one, so 3 into bracket n minus 1, n minus 2 factorial divided by n minus 2 factorial. Again this and this gets cancelled. So we are left out with n into bracket n minus 1, n minus 2 is equal to 3 into bracket n into bracket n minus 1. So with this, if you simplify this one gets cancelled. We are left, and this n and this n gets cancelled. So we are left out with n minus 2 is equal to 3. N minus 2 is equal to 3, which will give you n is equal to 5. So one another problem, npn2 plus 50 is equal to p into bracket p of 2n2. So this is equivalently I can write it as 2 into np2. It is meaning is np2. So that is why I have written here n into bracket n minus n into factorial divided by n minus 2 factorial plus 50 I have kept as it is, and this it is 2n. So 2n factorial divided by 2n minus 2 factorial. This I have written here. So now with this 2 into n into bracket n minus 1, n minus 2 factorial I can write it divided by n minus 2 factorial plus 50 I have kept as it is, and this one I have written like this 2n into bracket 2n minus 1 into another bracket 2n minus 2 factorial divided by 2n minus 2 factorial. So here this one and this one gets cancelled. We are left out with 2n into bracket n minus 1, 2n n minus 1 plus 50. So this is in this side. So here again these two will get cancelled. We are left out with 2n to other bracket 2n minus 1. So with this I have taken two common. So what will happen, n into bracket n minus 1 plus 25, and this 2 gets cancelled. So you are left out with n to bracket 2n minus 1. So here if you simplify this, n square minus n plus 25, which is equal to 2n square minus n. So simplifying this, you are going to get n square minus n square is equal to 25. That is, this n gets cancelled. Okay, then 2n square, this minus n square, that is n square. So you are left out with n square plus is equal to 25, which is equal to plus or minus 5. Okay, so hence the required number n is equal to 5. Okay, next example. um, to prove the following conditions, that is, establish the following identities. That is, you have to prove that LHS equal to RHS, or from RHS LHS you are going to get RHS. So n plus 1 PR is equal to n plus 1 uh, into NPR minus 1. Okay, now I will consider LHS n plus 1 PR, which is given here. So applying the rule NPR. Okay, so what is NPR? NPR is equal to n factorial divided by n minus r factorial. In the same way, if I apply here, I am going to get it as n plus 1 PR, which is equal to n plus 1 factorial divided by n plus 1 minus r factorial. Okay, so now which is equal to n plus 1 into n factorial, I can write with this. Okay, divided by n, so n minus r, n minus r plus 1 factorial, n minus r plus 1 factorial, I can write it as. So with this what I got is the RHS part. LHS equal to n plus 1 PR, which is this, I can write it as n plus 1. So this I can write it as r minus 1 factorial. So np r minus 1. So n factorial divided by n minus r, minus of minus, it will become plus. So I can write this as n plus 1 into np r minus 1. So thus I can write it as n plus 1, n plus 1, n plus 1 plus 1, n plus 1 n into npr minus 1. So similar kind of problem, which is npr is equal to n minus r plus 1 into npr minus 1. So now what I will do is, I will take RHS part and I will prove LHS. So consider RHS, that is n minus r plus 1 p r minus 1. Again apply this particular rule, npr is equal to n factorial divided by n minus r factorial. With this, n minus r plus 1, it is already there, I will keep as it is, and here I will apply the rule. So that is n factorial divided by n minus of this, that is minus r minus 1 factorial. So with this, n minus r plus 1 divided by n minus r, then minus of minus plus 1. So this I will write here, n minus r plus 1. So now this n minus r plus 1 factorial, I can write it as n minus r plus 1, 1 less. So 1 n minus r factorial. So n minus r, so 1 less, n minus r factorial. So this will get cancelled. So we are left out with n into n factorial divided by n minus r factorial. So which is equal to npr, which is my LHS. So I started with RHS part and I have obtained with LHS part. Okay, another one which is other problem. How many words can be formed by using the letters of the word chemistry? So, how many number of possible combinations? So, and also how many words of four distinct letters can be formed? If you look at, there are nine different words: C, H, E, M, I, S, T, R, Y. There are nine different letters. So all of this can be formed by taking all the letters at a time. So if you look at in this, it will be 9p9. So which is equal to 9 factorial. If you apply the formula also, 9 factorial divided by 9 minus 9 factorial, which is 0 factorial, so that it is 9 factorial. If you find this, you will have 3 lakhs 62,880. So that is represented as 9p9. So when the number of words with the four distinct letters, so it is 9p4. Okay, so which is 9a into 8 into 7 into 6, which is 9 factorial divided by 9 minus 4 factorial. So you will get downside, it is 5 factorial in the denominator. So that is why I can write it as 9 into 7 into 6 into 5 factorial. 5 factorial gets cancelled. You will get 3024. Okay, with the similar kind of what we have done with respect to NPR. So now it is NCR. So NCR, this is C of NR is equal to what? NCR. So this is NCR minus 1, which is equal to N plus 1 CR, or C of N plus 1 R. So as I did in the previous problem, so NCR is equal to, I applied the formula here, N factorial divided by N minus R factorial into R factorial, plus again this one I am applying here, N factorial divided by N minus R, that is N minus R plus 1 factorial divided by R minus 1 factorial. Okay, this I have written here. So now here n factorial divided by n minus r factorial, n factorial, n minus r factorial I have kept as it is, but this r factorial I have written it as r into r minus 1 factorial. Okay, so plus n factorial, then this r minus 1 factorial I have kept as it is, and this one n minus r plus 1 factorial I can write it as n minus r plus 1 1 less. So if I write n minus r plus 1 minus 1, so that would be 1 1 gets cancelled, you are left out with n minus r factorial. So I have written with this. So n factorial and r minus 1 factorial and n minus r factorial are common factor. So when if you take out this common factors, then I left out with 1 divided by r in this part plus n factorial divided by this one. Okay, so with this, now, okay, so now I have taken this, and n into bracket n minus r plus 1 is LCM. So when you take this into r, so when you solve this, you will get n minus r plus 1 plus r. So this r gets cancelled. You have left out with n factorial divided by r minus 1 factorial into n minus r factorial as it is. So here you are going to get n plus 1 divided by r into bracket n minus r plus 1. So this is what the particular step is. Now, so this put together, this and this, I can write n plus 1 into n factorial, that I can write it as n plus 1 factorial divided by, so r minus okay, this r and into this r minus 1, so I can write it as r factorial. Okay, so now this n minus r factorial into n minus r plus 1. So this I can write it as n minus r plus 1 factorial. So which is equal to n plus 1 r factorial divided by r into n plus 1 minus r factorial, which is I can write it as n plus 1 cr, which is equal to RHS. So thus C of n r plus C of thus C of n comma r plus C of n minus n comma r minus 1 is equal to C of n plus 1 r. So other problem we will see C of nr which is equal to C of n minus 1 r and plus C of n minus 1 r minus 1. So now I'll take RHS first, then I will get the LHS. Okay, so now I apply the formula here. I will get n minus 1 factorial divided by n minus 1 minus r factorial divided by r factorial. Okay, plus n minus 1 factorial divided by r minus 1 factorial into n minus r factorial. So that is n minus 1 minus r plus 1. So here with this now if I write n factorial divided by r factorial, I have written here r factorial divided by n minus r minus 1 factorial. So which is equal to r minus 1 factorial plus this one, this is gets cancelled. I have left it with n minus r factorial. So now n factorial divided by, I have taken this r factorial, I have written it as r into r minus 1 factorial. This I have kept as it is, n minus r minus 1 factorial. So here n minus 1 factorial, r minus 1 factorial, I have kept it as it is. Now this n minus r factorial, I can write it as n minus r. So again n minus r minus 1 factorial I can write it. Okay. So next is taking the common factor, that is n minus 1 factorial divided by r minus 1 factorial into other bracket n minus r minus 1 factorial. Here I left out with this part 1 divided by r plus 1 divided by n minus r. So n minus r factorial divided by r minus 1 factorial into n minus r minus 1 factorial. So you take LCM, so you will get this one n minus r plus r. So now this one gets cancelled. So n minus 1 factorial into n divided by r minus 1 factorial into n minus r minus 1 factorial into other bracket r into n minus r. So this I can write it as n factorial because n into n minus 1 factorial is n factorial, and r into r minus 1 factorial I can write it as r factorial, and this n minus r into n minus r minus 1 factorial I can write it as n minus r factorial. So with this is a formula for C of nr, that is NCR. So NCR, so C of nr is equal to C of n minus 1 plus C of n minus 1 r minus 1. So hence it is proved. Okay. So we are going to take some different set of problems with this. Uh, 6 boys and 4 girls got selected as, then I need to a 5-member council has to be formed from elected representatives. So that is in a team you have to represent 5 different people. So in how many ways this council can be formed such that in a team there are 3 boys and 2 girls, at least 2 girls and at least 3 boys. Okay, solution is very simple. So there are six boys, so I'll take them as 6b, and there are four girls, I'll take them it as 4g. Okay, now the possible ways. The first possible ways is three boys and two girls. So that is, I can write it as, the first combination will be out of six boys, there should be three boys. Okay, next, and two girls can be selected out of four girls is 4c2. Okay, so first option, then the total team will be this and this. Okay, now this 6c3 is here, which is 6 factorial divided by 6 minus 3 factorial into 3 factorial, and this I can say it as 4 factorial divided by 4 minus 2 factorial into 2 factorial. So which is equal to 6 factorial divided by 6 factorial into 3 factorial into 4 factorial divided by 2 factorial into 2 factorial. So if you find out this, 6 into 5 into 4 into 3 factorial divided by 3 factorial, these two gets cancelled, 3 to 1. Okay, and here it is this 2 factorial, this 2 factorial gets cancelled, so 4 into 3, so you will get 20 into 6, which is 120 ways where the first set of counseling, first option of three boys and two girls will be selected. So second option what they have given is at least two girls. So that means what, I can have maximum of four girls, and even there may be of two girls, even of two girls. If I choose minimum girls, then remaining is three boys. So because there should be of five members in a particular council. If there are three girls, then number of boys is only two. Then if there are four different girls, then only one boy should be there in that particular team. So the number of first one, the number of possible outcomes or possible ways where the council can be formed is 6c3 into 4c2, which is 120 ways. Second one is two boys is out of 6, so that is 6c2. Then three girls out of 4, so that is 60. And last one is 6c1 and c44, which is of 6 ways. So all these are all correct only. So all these are all the total number of possible combinations. So this is one, this one, and this one. So totally 120 plus 60 plus 6 is 186 ways where the second option can be formed. Third part is at least three boys. So when I say there are at least three boys, then there are three different options. One is minimum three boys and two girls. Another one is four girls and four boys and one girl. And the last option is only all boys. So with this, I can have six boys can be the total number. So three boys will be selected. So 6c3, and two girls, that is 4c2. If you calculate these values, you will get 120. And second option is 6c4 into 4c1, so that you will get it as 60. And this one I'll get it as 6 c5 and 4c0, you are going to get it is 6. So the total number of possible ways is all three, and you are going to get it as 186 different ways where at least three boys can be there in a council of 5 members. Okay, there is another question that a particular question paper as two different parts, A and B, where each containing four questions. So that is part A contains four questions, part B contains four questions. In how many different ways can answer five different questions by selecting at least two questions from each part? Okay, so there are totally four questions in part A and part B. So each contains four questions, and how many ways he is going to solve by selecting two different questions. If you look at here, I have taken uh, part A contains four questions, part B contains four questions. So in two different questions can be answered in this way. So part A contains two questions, part B may contain three questions, so totally five questions. In other way it is like part A contains three questions, part B may contain two different questions. So the total numbers will be this plus this. Okay, so now part A, this one, and part B. If you look at here, there are four questions. So this can be answered is 4C2 and this is 4C3. So there are four questions each. And here it is 4C3 here, and here it is 4C2. If you find out this particular value, that is 4C2 and 4C3, you are going to get it as 24, and similarly here also you are going to get 24. So the total number of possible uh, ways is A plus B, which is equal to 48. Okay, so one last problem where you need to find out the value of n and r. If P of nr, that is npr, is equal to 5040 and ncr is equal to 210, then find the value of n and r in the given particular problem. So now I know that ncr is equal to npr divided by r factorial, which is a given problem. We know the formula. With this, I can find out r factorial, since I know the value of p of nr and cnr. So r factorial is equal to 5040 divided by 210, which is r factorial is equal to 24. So now c of nr is 210. Now r is equal to 4. So I can write it as c of n comma 4, which is equal to 210, by substituting the value of r with this, because r factorial is equal to 24. I can find out r is equal to 4. So now if you look at c of nr is equal to 210, so the same thing I have written here. So we always, the n should be, to find out n, this value of n should be always greater than or equal to 4 only. So n is greater than or equal to 4. So by taking the value here 4, 5, 6. Okay, if n is equal to 4, then what I am going to get? If n is equal to 5, I will get 5c4 is equal to 5. If n is equal to 6, I will get 35. If n is equal to 7, that is c7, n 7c4, I am getting 75, 35. N is equal to 8, that is 8c4, I am getting a 70. So I am doing some trial and error methods here in order to get 210 with this, which is the given value. So n is equal to 10, r is equal to 4 with this particular given formula.